Hi, today we're going to look at reasons for using direct injection or line isolation boxes with digital guitar amp modelers along with comparisons of several of those devices. For the modeler, I'm using the Strymon Iridium. It's a good candidate for this demo because it has unbalanced outputs, which means it won't be optimal for long cable runs on its own. I'll get more into that later, but that's the biggest takeaway. DIs or LIs are best for long cable runs. I'll be using the Iridium in mono since not every device I'll be showing supports stereo. I'll be trying 6 different DI and LI products from Radial Engineering, Walrus Audio, and Pinstripe pedals. The JDI, J48, JPC, Pro D2, Canvas, and DISO Plus. These are a mix of passive models with audio transformer isolation, as well as active models. Instead of a mixer channel, I'll be running all of these signals into a Focusrite ISA Preamp, which provides inputs for adjustable line, instrument, and mic levels. This means I'll be able to demonstrate the nominal setup for each type of signal being sent without having to switch to any other gear. Think of this preamp as an input section of a mixer channel. It has some added bells and whistles, but it's essentially still the same thing. I want to cover a bit of terminology before getting into the demos. What's the difference between balanced and unbalanced signals? The difference is noise. A balanced signal uses an extra wire, and gear can use that extra wire to filter out the noise that gets picked up over a longer cable run. I've also mentioned different signal levels. There are 3 types of signals that are common to connect to a mixer channel. These are microphone, line, and instrument. Mic level signals are low output, but are also low noise due to them being balanced. When most engineers talk about microphones and mic level, you can be assured they are referring to the professional low Z or low impedance kind. These mic signals will almost always use XLR connectors. Some will say transmission length is good out to over 300 feet before beginning to notice any high frequency roll-off. That's the least distance one can expect without any signal degradation, but it can also be much longer than that. Instrument or high Z input is intended to plug your high impedance, unbalanced electric guitar or bass directly into. An instrument cable is typically going to be the 1/4-inch TS connector that you use all the time with guitars, pedals, and amps. You'll virtually never use this at a gig connecting to a mixer, because this type of signal cannot stay intact well over a long distance. Some will say about 50 feet before noticing high frequency roll-off or picking up noise. It depends on a variety of factors. Line level has the hottest nominal signal of the 3. Being a hotter signal can mean better signal-to-noise ratio and even longer distances. These signals can be either balanced or unbalanced, with balanced signals, again, being superior. You'll find line signals that use TS, TRS, or XLR connectors, so you can never be certain what kind of signal you're working with judging only by the connector type. Now I want to talk about the practicalities of routing signals at a gig and why DI boxes are the typical solution for long cable runs. There are many instrument sources that an engineer must get from the stage to the front of house mixer. The most common signal source would be a microphone, which implies XLR connections receiving low output and low impedance signals. These require microphone preamps to bring the level up before processing the sound through other gear. A front-of-house setup is always ready to receive mic signals, with most or all of the XLR drops on stage running into microphone preamps already. What that usually means is any instrument or gear that you put on stage which doesn't have a microphone next to it or doesn't already send a balanced mic level signal will likely get converted with an appropriate DI box. This normalizes the entire operation, and it means the engineers aren't having to question and deal with a multitude of different signals coming from the stage to the mixer. Musicians can often be unaware of what's really going on here. Many times, the engineer will simply assess the situation and provide the DI box, unless, of course, you have one of your own to provide. That's enough primer. Let's start looking at specific gear examples. We'll start by establishing a baseline for the Iridium. In situations where you can use a short cable run, like a home recording or rehearsal environment, the Iridium is perfectly capable of working without a DI or line isolator. I'll be plugging the Iridium into the line input of the ISA preamp using this short TS cable, and I'll always be keeping the Iridium volume level set at noon. I've set the line input gain to 0, and I can use the trim knob for finer adjustment. The JDI is Radial's premium passive direct box. It uses a Jensen branded transformer for audio isolation between the input and the output. Isolating the audio signal this way means there's a magnetic bridge between the input and output with no wires between them. The potential for noise from direct current or a ground loop is virtually eliminated, and because it's passive, it isn't a source for noise itself. A passive DI is the typical choice when you need to plug in an active signal from the stage, such as the signal coming from a synth, or a bass that has battery-powered electronics, or in this case, a digital guitar amp modeler. I'll take a little more time to explain the features of the JDI, so I won't need to repeat those explanations for other boxes when the same features come up again. The 1/4 inch input is for the unbalanced instrument or line level signal that your modeler will plug into. The through output is a split of the input signal. You typically use this to run your modeler signal out to a powered monitor on stage if you wanted to use one. The pad switch can be engaged if the level of the input is extremely high, causing unwanted distortion. The merge switch changes the through output into a second input, then merges that signal with the main input. You'd use this if you had a stereo modeler, but could only send a mono signal to the front of house, or if the sound system itself was mono. The output is an XLR balanced mic level signal that you run to the front of house and a microphone preamp. There's a ground lift for the ground pin of the XLR output in case you do encounter an extreme situation and have noise resulting from a ground loop. The polarity switch reverses the polarity of the mic output. You would typically use this if you're also using an amp on stage, and the polarity of the amp speaker was opposite the polarity of the sound system. When that happens, the two sounds will cancel out some of each other's frequencies, and the closer in volume the two sounds are, the more you'll notice an increasingly hollow or thin sound overall. The speaker switch you won't find any use for in a guitar amp modeler setup, so I'll skip it. Now, using the same short instrument cable from the previous example, I'm sending the output of the Iridium to the input of the JDI. And to make things more real world, I'm using 100 feet of XLR cable to run between the DI box and the mic preamp. On the mic preamp itself, mic input is selected, and I have the gain and trim settings dialed in. I have one additional control for mic input that selects the input impedance. This allows for a better impedance match when using different microphones. You don't want your input impedance to be too low, or it'll have an effect on the high frequencies and the level, as this demonstrates. A general guideline is that the input impedance should be around 10 times greater than the impedance of the signal. The JDI lists the output impedance at 150 ohms, so somewhere around 1.5 kilo ohms would be adequate. The ISA 110 setting is 1.4 kilo ohms, and the medium setting is 2.4 kilo ohms, so either of those should do fine. When in doubt, go with the higher setting, and always use your ears. I know that was a lot to cover at once, but in practice it's really pretty simple. Here's the results. The Pro DI is Radial's more affordable passive direct box. I have the stereo version called the Pro D2. It has transformer isolation just like the more expensive JDI, but instead of a Jensen branded transformer, it uses a less expensive Eclipse transformer. Features are also more basic, Besides the typical in, through, and out, it has one pad switch for each input and a ground lift. The output impedance is listed at 150 ohms, just like the JDI, so I'll use the same settings on the mic preamp. The J48 is Radial's premium active direct box. An active DI is actually a lot like a preamplifier. It uses active electronics to boost a very low input signal, even though the result is still a relatively low balanced mic level signal that needs to run into a microphone preamp. Unlike a passive DI, there's no audio transformer providing isolation, and that does mean a higher noise floor, but if done well may not even be noticeable. What an active DI excels at is converting signals from passive unbalanced sources, like that of the direct output of a guitar or bass that uses passive magnetic pickups. Active DIs also preserve higher frequencies, which audio engineers sometimes call air. This doesn't mean that an active DI can't be used for a digital guitar amp modeler. It might not be the most recommended solution, but it's still tons better for a long cable run than no DI at all. And since I want to make this video about DIs comprehensive, ignoring active DIs would be a glaring omission. Most of the features of the JDI are also present on the J48. The J48 includes a low-cut filter, which is the kind of thing that's normally handled at the mixing board or mic preamp. But then again, so is reversing polarity, and that's still a common feature on DI boxes. It doesn't hurt to have the same options in multiple locations. The J48 is powered over the XLR connection from the mic preamp, which supplies phantom power. If your preamp can't send phantom power, the J48 will be useless to you. The hookups are all the same like on the JDI, but I needed to reduce the gain on the mic preamp as the J48 is sending a higher level mic signal than the JDI, and I went with the 1.4 kilo ohms impedance selection. The JPC is Radial's DI designed for laptops and other digital inputs like iPads and CD players. Unlike the other DIs shown so far, this one is not designed for instrument level input. And if you used a passive input like a magnetic guitar pickup, it'll load the signal down and not give a very satisfactory response. However, as a DI box designed for digital devices, it's an interesting and viable choice to make for a digital guitar amp modeler. It's a stereo DI that has 1/4-inch TS, 1/8-inch TRS, and RCA inputs. It lacks any 1/4-inch through outputs though, so it wouldn't be a good all-in-one solution for splitting a signal to send to a powered stage monitor. The JPC has a hybrid approach to audio isolation. According to Radial's documentation, the audio input is isolated using a 1-to-1 transformer. After that magnetic bridge, the active circuitry takes over to drive the signal to the output, including the task of impedance conversion and balancing. And like the J48, it needs phantom power. Here's how I've set the preamp options. Walrus Audio has made the Canvas to be a versatile solution that can do either DI or line level isolation in one box. It's a passive unit and uses transformer isolation on the audio signal. The version I'm using is stereo, and it has through outputs for sending signals to any powered stage monitors. The sum switch takes the left and right inputs and combines them on the through output for sending to a single amplifier or monitor in mono. It has a pad for handling extremely hot signals when the box is in DI mode, and it has a ground lift. The DI-LI switch changes the mode from direct injection to line isolation. We'll look at DI mode first. I'm running this into the mic preamp, and these are the settings. Line isolation is all about taking an unbalanced line level signal and converting it to a balanced line level signal, essentially preserving the hotter signal level that's already coming in and adding the benefits of an isolation transformer. Is line isolation better than DI? It really depends on the application. On the plus side, you don't need to use a mic preamp for a line level signal. And the hotter signal also generally means a better signal to noise ratio. It's a lot like plugging the Iridium directly into the line input on the mixer, except in this case, the signal is balanced and supports a very long cable run. A line isolator could be ideal if the front of house is set to accommodate line signals from the stage to the mixer. However, if the engineer is already running all of the XLRs from the stage into mic preamps, they might tell you that the signal being sent is too hot and ask you to adjust it somehow. Also, due to the higher level, there's the added possibility of crosstalk with other signals. It's a good idea to understand these possible effects so that you aren't caught off guard if they should arise. Here's the setup on my preamp. Remember, with line inputs, there's no impedance selection necessary. Pinstripe Pedals has the DISO Plus, a line level isolation box. It's a stereo passive unit with Jensen transformers for audio isolation. It has 1/4 inch outs that are throughs for sending the input signal to powered stage monitors. 1/4 inch sum takes the left and right inputs and combines them on the 1/4 inch outs for sending your stereo signal to a amplifier or monitor in mono. XLR sum takes the left and right inputs and combines them on the XLR outs for sending your stereo signal to the front of house in mono. And there's a ground lift. Here's the setup on my preamp, and again, with line inputs, there's no impedance selection necessary. Also, I'll keep mentioning with line level that you want to know if your front of house engineer is running the XL drops into mic preamps for the reasons I've already covered. If they do ask you to turn something down, don't forget that the Iridium has a secondary trim control, and that works across all presets, so you may be able to use that to reduce the signal level enough. Those are all the DI boxes I have to show you. Hopefully I've explained things with enough detail that anyone can size up which type of DI is the right choice for a given situation. Now I'm going to finish by taking us through a bunch of quick side-by-side comparisons and null tests. A null test demonstrates how similar two sounds are compared to each other. During a null test, if you hear nothing at all, then the two sounds are identical. Whatever you are able to hear, those are the frequencies or noises where the two sounds are different. First, I'll do a control. These are two separate recordings with the JDI using the same looped recording. This is as close as I'm able to get using my gear and technique for 2 recordings of exactly the same source to null out. For the remaining comparisons, the only difference between each recording will be the methods used to connect the Iridium to an input and the related settings on the ISA-1 preamp. The only processing I've done after the recordings were to make very minor level adjustments that are needed to perform the null test.